Welcome back. There's been a big gap since I did question 6. I started this a couple of years ago, but it seems to be being used more and you're finding it useful. So I'm going back and finishing off this paper. So I'll start with question 7, and as long as you tell me that's useful, I'll keep going and make sure I've done the rest of this paper. Paper 1, 2018, 7A, and we start with a multiple choice question. We need to identify the non-renewable source of energy. Oh, Pedro's let out some natural gas. And in fact, that's the one that probably, if it's going to catch you out, it's going to be the natural gas one. I think sometimes students think, oh, natural, so isn't a natural, does that mean it's renewable? No, you've got to remember natural gas is made over millions of years and we've been burning up in hundreds of years. So natural gas is the non-renewable and therefore is the correct answer for 7A. On to the next one. Why are renewables providing an increasing fraction of electricity? So this is 2 marks, so we need a statement and then a reason. So we've increased the use of renewables. Why have we done that? Well, we've increased the use of renewables, so there's a mark. In order to reduce carbon emissions. So a statement and a reason. I think lots of people, when I've marked this, have struggled to get the 2 marks because they kind of feel like maybe that first statement's in the question, which I can see. It's easy to think that, but if it's 2 marks, just think I need to give a statement and then give a reason for that. You could also do the reverse argument in that there has been decreased use of fossil fuels. Could be your first mark, and then I would keep the same argument there in order to reduce carbon emissions. The mark scheme says other valid reasons, but I think that's the one I would go to, the main one. Okay, into a calculation now. So electricity can be generated using a water turbine and it gains energy by falling from the top of a dam. So we're asked actually about the height. The height that 7 kilograms of water would need to fall in order to gain 1300 joules of kinetic energy. So we've got this reservoir, water can come through the reservoir, turn turbines and generate electricity. Now this one, many times I've seen people try and do a kinetic energy calculation, okay, but this is actually a gravitational potential energy calculation. Let's just, we'll write this out and then we'll talk about why that is. So gravitational potential energy equals mass times gravitational field strength times height. Okay, so it's what height, and so we obviously need an equation with height in it. What height does 7 kilograms of water need to fall in order to gain 1300 joules of kinetic energy? So this is working on the principle that as it falls, GPE will be converted into kinetic energy. So the principle is that if it has 1300 joules of kinetic energy at the bottom, I don't know, down here, then it's because it had 1300 joules of GPE at the top. Now, I've actually missed a word, so I'm just going to add this in. This is the minimum height. So we're going to assume that all of the GPE is converted to kinetic energy. Now, obviously, in reality, that won't be the case, but they're not going to expect you in a calculation to know how to kind of factor in the efficiency. So that's why it says minimum height. In reality, it would need to be higher because you'd lose some energy. But we've got this 1300 joules of kinetic energy. Now, as I always say, write down the information that you have down the side. So we've got 7 kg is our mass. We've got the energy. I'm just going to put E for energy because we don't want to confuse ourselves with the kinetic energy at this point. And G, you need to know newtons per meter or meters per second squared, because go into that in another video if you want me to explain why that is, why G has 2 different units, but 10. You've got to remember that the gravitational field strength on Earth is 10. Okay, so now we've got 3 parts and we need to work out height. So we're going to rearrange this equation. We're going to move the M and the G underneath the GPE. So again, if you need help with equations, I can do a separate thing on that, or you can talk to me about that. But for now, height will equal GPE divided by M times G. So that gives us 1300 divided by 7 times 10 gives us 1300 divided by 70, which equals 18.57. We're going to stick with 2 significant figures. It's not in the question, but let's get into good habits. So I'm going to leave that as 19 meters. Make sure it doesn't look like a 4. 19 meters is the minimum height it needs to fall. So do not confuse that with a kinetic energy calculation. We move on to the next question, and here we do have a question on kinetic energy. So here we are told that at the bottom the water goes through a turbine. Here's my little diagram of water going through the turbine, making it spin, and it's saying 8 kilograms of water has 1100 joules of kinetic energy, and we are asked in this case to work out what the speed of the water is. Let's make sure we've got the units on there. So this is a 3-mark question. Again, let's write out the equation that we're going to start with. Kinetic energy equals half times mass times velocity squared. Let's write down the information we have. We've got the mass is equal to 8.0 kg, and we've got the kinetic energy is equal to 1100 joules, and what we're trying to work out is the velocity. So I'm going to rearrange again. I could do separately on rearranging, so I'm going to go through this fairly quickly, but we're going to get the idea. Let's do it at least this step. So we're going to get the idea that V equals 2 times the kinetic energy divided by the mass, and therefore V squared equals 2ke divided by the mass. So we're going to get rid of that square. We're going to do the square root of 2 times ke over m. So that's 2 times 1100 divided by 8.0 and square root all of that. So that is going to give us a value of the velocity or the speed of 16.58. Again, I'm going to leave that to 2 significant figures, so I'm going to leave final answer as 17. Remember, the 16.58 would get you the mark because it doesn't specifically say it has the correct number of significant figures, but just to get into good habits, there are the data that we're working with. The smallest number of significant figures in the data is 2, so that's really how we should leave our answer, 17. Do not panic if you have struggled with this question. It's one of the hardest. I often use this question at year 10 and very few people get it right. So, don't panic. We're going to learn what it's trying to ask you to do so that in future, if you've got a similar question, you'll be able to do it. And if you have got any marks on it, really well done. But let's go through it now. So first off, I've got another incredible diagram of a turbine, this time a wind turbine. So we have Pablo here. It was a quiet, still day, so he's provided some wind for us. And before the wind goes into the turbine, it's traveling at 15 meters per second. After it passes through the wind turbine, it's traveling at 13 meters per second. So essentially what's happening here is, right, the way a wind turbine works is it takes the kinetic energy of the wind and it transfers it into kinetic energy of the turbine. And so it makes sense, right, that the air going in is going faster than the air coming out the other side. So what you are asked to do is work out the percentage of kinetic energy transferred from the air. This is where we need to look at this graph. So on the x-axis we've got wind speed, and on the y-axis we've got the kinetic energy of air in kilojoules. So hopefully, kind of given this preface, we start to see, okay, so firstly, what's the difference in kinetic energy? So we're going to need to, again, use your rulers. I'm going to try and do my best here to draw a straight line, but use your rulers, please. So 15 meters per second, we've got this line here. Try and not make too much of a mess. Okay, and that's going to come out there. And 1, 2, 3, 4, 5. So each square is 400 joules. Because it's kilojoules, so 400 joules or 0.4 kilojoules. So we've got 4.4, 4.8, 5.2. So at 15 meters per second, there is 5.2 kilojoules. Oh, sorry, let me just correct that. There is 5.2 kilojoules of energy. And then let's do it in a different color just so we don't lose ourselves. And then at 13 meters per second, to be careful because 2 squares is 1, so that's 11, 12, 13. Oh, a bit windy-windy, but we can see that's the point I'm interested in. And conveniently, that pretty much goes to 4, doesn't it? So at 13 meters per second, we've got 4.0 kilojoules of energy in the air. Okay, hopefully with more practice I'll get better at writing with this pad, but the percentage of energy transferred from the air to the turbine is what we're interested in. So that's going to be the amount transferred divided by the total to start with. So the amount transferred is going to be 5.2 minus 4.0, which is going to give us 1.2, and then we're going to divide that by the amount we started with, which was 5.2, and then so I missed off, and then obviously we need to then multiply that by 100 to get it as a percentage. So if we do that, we get 23%. 23%, and that's going to be my answer there. Now, what happens if you read the graph slightly differently? So just to be clear, the mark scheme allows values between, be as precise as you can, but it allows values between 5.0 to 5.4 for the 15 meters per second air, and it allows values of 3.7 to 4.1 for the 13 meters per second air, and that would give you a range of final answers of between 18% to 32%. So if you got a different answer to me, but you did what was suggested here, so long as you are within the range of 18 to 32%, which is the possible ranges depending on which values you picked, then that would still get you full marks. And in fact, mine's not exactly. The mark scheme says 25%. They've taken this value as 3.9. But that will all still, anything between 18 and 32% will get full marks. But that's a super tricky question, so I hope that was useful. That is it, I think, for question 7. So join me for question 8 if you need help on that. But otherwise, I hope that was useful. Bye from Pedro, bye from me.